company that combines technology and marketing to help hotels online and leverage the entire distribution chain. DH provides localized support, service, and tools to over 12,000 hotels worldwide, which with its global network of 500 partners or more than that. The Edge ever-expanding ecosystem is a positive place for hotels to do business and grow. So we are in Asia, Europe, and starting Americas also, and we have very many hotels using our technology. Today I will talk about integrating a stack into legacy code. So a brief introduction of what is legacy code, at least what I consider to be legacy code. And if you have any question during this presentation, you can ask the questions in the chat. Maybe there is someone who will ask that questions, or maybe at the end I will ask the questions, answer the questions. So let's start. So legacy code is everywhere. For example, Windows XP was developed and maintained for 12 years by Microsoft, and then on April 14, 2009, it wasn't supported anymore. So people have to change that software. AngularJS also was replaced by Angular, a newer version, but despite having the same name, are completely incompatible. And Classic ASP was the Microsoft first server-side scripting engine released in 1996. People use it for many years, and still today we can find web pages running Classic ASP. But it's a very old technology. In one of my previous jobs, I worked in the migration of some remaining parts from Classic ASP to ASP.NET. And when I started working for the Edge 3 years ago, I heard also that just recently they had finished the migration from Classic ASP to ASP.NET, which had been running 14 years at the Edge. Also at the Edge, last Friday, a web service was decommissioned after several years of good and loyal service. So we can find a legacy code everywhere, and we have to manage it. As an example of how quickly we can adopt new software and how slow is the decommissioning of that software, we have here an overview of Windows XP, which support ended in April 14, 2009. And in this graph, we have data from January 2009. So the market share of Windows XP was a little low, the 80%, and you can see that for many years the market share was significant. And then on July 2015, Windows 10 was released, and the adoption was very big. And still today, the Windows XP has a 0.7% market share of Windows desktop. So even 11 years after the ended of support from Microsoft, we can still have this software running on computers. But what is legacy code? So from the previous examples, we can say that legacy code is unsupported software, and that is true, but there is more to it. This is a famous quote of Michael Feathers. He says that legacy code is code without tests. In my opinion, this is a very simplistic view. not that he is wrong, but because he's very right. Code without tests is very much legacy code. But I'm here to tell you that there is code with tests that could be considered legacy code. So in my experience, legacy code follows some characteristics. The onboarding time is very high. Maybe you have experienced this as new hire. You take for the first time a project, the build does not work. When you manage to build the program, you try and run it, and then there are runtime errors. The configuration is outdated. You fix it and try to run again. It appears that as a requirement for the program to correctly run, you have to log in somewhere. So you manage to do that. So you log in, and the environment you are testing against is also outdated, and so on and so on. So you pass the next few days, sometimes weeks, trying to get the most basic output of the program. This is only on the onboarding part. Next, you have to debug this software because legacy code is code we have to maintain. So you have to debug it in order to fix some part of that program. So after being able to run it, you have to manage to enter new inputs so you can hit the desired block of code you want to fix. Then you have to retrieve the outputs of the program and make sense of them, which turn out to be also very difficult. So from where I just said, it follows that it is expensive to modify, and new features or changes existing, or so adding new features and changing the existing ones is very difficult and expensive because it's longer and longer each time, and each time we modify the code is of lesser quality. Michael Feathers, also analyzing what is legacy code, say that legacy code is code with a big amount of technical debt. So technical debt, he say, can be estimated by measuring the effort of refactoring needed to add a new feature non-invasively. So you can estimate that in years, years being a very common figure. So we have established the characteristic of legacy code and maybe found a method to estimate how many legacy code there is and how difficult it is to modify. But how it comes that there is legacy code everywhere, how it is the most of the software out there will be one day legacy code. So a simple answer could be because programming is hard, but a more elaborated answer starts with because programming is often misunderstood. So as I said, programming is often misunderstood. There are some people that regard programming on the eyes of this classical view. In this classical view, programming is considered an activity of production of code, so the text of the program, production also of technical documentations, specifications, user guides, etc. And in this view also, the programmer is regarded as a low responsibility worker, easily replaceable and of only brief education. As opposed to it, Peter Naur, in its paper Programming as Theory Building, which I recommend everyone to read, exposes this other view where the primary activity of programming is the programmers building up knowledge. So the programmer should first form a certain insight of the real world problem and they try to produce a limited answer to that problem in the form of a program running on a computer. So the programmer should be also able to respond to changes in that portion of the real world by changing the program in the best way. forming. So in this view, the programmer, while building the program, is building also a theory of that program. And that theory is composed by explicit knowledge, which is the code and the documentation of the code, but is mostly composed by tacit knowledge. So the tacit knowledge is the insight of the programmer has of the real world problem he's trying to solve, the reasons they had to code in a certain way the program, and also all the accumulated experience of the program, building up similar theories or other kind of theories or programs. So in this view, the programmer has to pass along those theories as a primary activity. And the tacit knowledge being the most extensive of the knowledge, the tacit knowledge being more extensive than the explicit knowledge, and built over a long period of time, it follows that code and documentation is insufficient. And in order to preserve the program and knowledge that went into its production, there had to be always a programmer or a group of programmers knowing the theory of that program, so the program can have a long life. So we can answer now why there is legacy code. So most of the time, those are programs built in the classic view. Most of the time, that kind of program could become legacy from the first line of code. In the other hand, if the program written with the second view in mind, the program can become legacy in the event of the dissolution of the team of programmers having the theory, or even in situations where there is high turnover, diluting the theory and not giving time to new programmers to build up that theory of that program. So other possibility is the one when the program is taken by another group of programmers without the correct theory. If the programmers can't rebuild that theory correctly, the modification of that program will resemble an integrated patches and will contribute to the decay of the program until it becomes unintelligible. So how we prevent this to happen? I will give the obvious answer. So you have to have experienced programmers that have to be able to understand the problem at hand and be able to produce very high quality code in response of that problem. They will build a theory which is for the most part on their heads. This theory you must to preserve. So you should manage to have a low turnover and effectively getting the programmers to pass along the theories to newcomers. So the program is correctly modified at each time. So this is very easily said, but it's very difficult to achieve. So there will be legacy code everywhere. So we should always ask, should we change it? Can we just delete it? Normally we can't just delete it because the code is making money, and yeah, if it wasn't making money, it wouldn't even be called legacy code. It just will be trashable code. It will be trash. So you have to work with this kind of code. And there are several possibilities to work with legacy code for change it. So working with the code as it is and trying to refactor it. There are several books on the subject. Michael Feathers and Martin Follower have written at least each a book on this subject. The other possibility is the full rewrite. So you take a new team of developers and give them the task to rewrite the software while another team continue to maintain the legacy code. I think this is always a very bad idea because if you start to develop a new software without proposing that software to the users, well, you are effectively producing legacy code. So you are trying to replace legacy code with legacy code. And the possibility that I prefer is a progressive change of the code, a progressive rewrite if it is possible. So you go for a progressive rewrite if refactoring it wasn't possible. And for the rewrite progressive of the code, so the team maintaining the software should be the one that rewrites a feature at a time, and possibly with enhancements for that feature that they are rewriting. So they get along with the product owner and decide together what are the changes that are most valuable for the customers or users. And then they define a parameter so they can rewrite this feature and maybe enhance, improve this feature. So once they have rewritten this feature and integrated it seamlessly in the software, they ship it and validate that feature with the users. So the users validate finally that that code is correct and they want to use it. And so you spend a little amount of time doing that. And yeah, so you effectively replace good code by legacy code by good code that the users love. And then when you have finished that feature, you start with a new feature that you can also define with your product owner and the users. So I will show a coding example, a way of integrating a new stack into a legacy application. So the legacy application I choose is an ASP.NET MVC application. So I choose this application because of the way we .NET developers start our career. This very Microsoft Visual Studio way, where when presented with a new problem to solve, the first thing we do is to choose the best application corresponding to a template in Visual Studio. And then we put all the code in that template without taking in consideration a lot of aspects of what software is and how to correct architecture it. Even less, we stop to think about the core of our application, the domain. So in my career, in the first years of my career, I have written applications this way. And it has taken me several years to break this dependency circle of Microsoft telling me how to do software and presenting me templates and tell me where to put my code. And so, yeah, building the understanding of how to correctly make software. I also choose ASP.NET because it is overly complicated as far as an implementation of the MVC pattern is concerned. In a typical case, someone choosing to do an ASP.NET MVC application understands nothing about the MVC pattern. And on top of that, the developer has to learn how to use this template. So they have to learn the HTTP application, the routing, the controller, the filters, the handlers, the model binding, the actions, the conventions, the templating language Razor. So there are a lot of learning, but all that learning is not that much useful. So yeah. So I consider that ASP.NET MVC application most of the time are legacy. For the new stack, I will be integrating into this legacy application. I choose ASP.NET Core, which is only the HTTP pipeline, which can be extended with middlewares, but assumes nothing and dictates nothing about the way you should implement your software. So you can really concentrate your effort in the domain. And ASP.NET Core is only a way to expose your application via HTTP. I have chosen also Giraffe, that is a lightweight library that gives a functional touch to ASP.NET. Fable, which is the compiler or transpiler that transform F# code into JavaScript. So you can run F# into the browser. And I have also choose Elmish, which is a MVU, so model view update implementation, as opposed to the ASP.NET MVC template. You must understand the Nvu architecture so you can use correctly Elmish. So you learn real useful concepts that are very simple. So here is a reminder of the Nvu architecture. You have a model that is used to render a view. The view can send messages that are used in the update function to update that model, and so change the view. So the model it changes a message at a time. So it is very easy to follow the flow of the data, and you cannot have race conditions in this architecture. I have already discussed this topic in another meetup. So at the end, I will share the link to the Edge YouTube channel where you can watch this topic in more in deeper if you want. So this is also nice to find in Twitter. There are people using this stack, which after 1 year only, they are very, very satisfied of this stack, which is known also as a safe stack because of the people that put it together, call it like this. And yeah, this guy who is a very talented .NET developer says that it have boosted its productivity. And in a personal note, yeah, we also in my team at the Edge, we have like 6-9 months working on with this stack, and yeah, we feel also the same. So I will pass to the code. So this is the new application I will be integrating with the old one, the legacy one. So I will explain maybe some parts of it. So here you have to tell Fable to, yeah, so the application will be deployed in IIS in a virtual path. So we have to tell Fable and the application in which virtual path it will be, so they can route the request in a good manner. So we have to tell that to Fable in this way. In the same way, we will have some information coming from the legacy code, information that is the most frequent, the authorization information of the user and the username or the things you want to handle here. Here you have the model. This is a very simple model. This is a very simple to-do application, which is the application which came directly with the safe template. So you can, when you say new application, new safe application, you have this. So here you have the model. You have the messages below, and next you have the init function. In this init function, we check if we are running in this. We are running from the legacy application, and we have a state. And if we don't have a state, we only give some new state. And here you have the update application, the update function, sorry. So the update function take messages and the model, and if following the messages, they modify you modify that model in the ways you want, and return when you modify the model, you return also a model and some commands, some new messages. And here you have the view, which takes a model. So with that model, you can render the view, which yeah, is very easy to render here with this DSL of HTML. So here is more like Fulma. There is a wrapper on to Bulma, which is like a bootstrap of CSS. And you also have a server part of the application. So your client of the application, which will run on the browser, can have can fetch data. So can go and fetch data from the server and your databases or things like that, or other services. And you have this initial state and this body content. So this body content, this function, will be published in a Nugget package. So it can be used by the legacy application. So the legacy application will pass the virtual path in which the application is deployed and the initial state. And with this initial state, we only will render a div telling the application that it is here the application should render, and we render also the initial state and the virtual path. So these are the variables that we can bind here to this variable with this code. This and this. So that is for the new application, and when you run the new application, you have something like this. So it's a to-do application. You enter things here and you create the list, the to-do list. And for the MVC application, we have this here. So it is a MVC template, MVC5, ASP.NET MVC5. You have your controllers, your content, your models here, your views. So very way of Microsoft of doing this implementation of MVC. And in order to be able to integrate the new application, you have to create a new controller that I called here a new app. In this controller, you need an action to render the view, render actually the application, the new application. And for the new application, you pass some information that you can actually here in a real application. You would have the context of the user, and from that context, you will have the client ID, the username, the rights, and the roles of the user, and in base of that, but you will construct the state. So you will construct the initial state. You will also check for the virtual path in which the legacy application is deployed. And having those inputs, you can use the function we packaged in the other side. So this function here, that is here used in a package, in a NuGet package. Okay, so once you have that, you can also you should also get the scripts, the JavaScript scripts and CSS styles that the new application generate. So you can do this in many ways, but here what we do is to say to this application, okay, the application, the new application is deployed in this path here, and the way to access this application via HTTP is here, is this one. And so we go and fetch the scripts that are in this URL, and the scripts and the styles. And yeah, we create the initial state. We create also this model of the application, of the new application, which is here in the models folder. And this model, you pass it to the index view, which is this one. So the index view render the content and render the scripts, and normally you are done. You have your legacy application integrated in the legacy one. So on the side of IIS, you have the legacy application and the new application that should be deployed side by side. So to have the same domain, the same URL, same domain at least. And yeah, when you run the old application, you have this. So that is a basic template of ASP.NET MVC. And normally in the real application, you will have some link to to navigate to the new application. And here I have this link here to navigate to the new application. So when I go to this application, I'm still on the legacy application here, but inside of this legacy application is running the new application. So in this way, you can integrate a very new stack, very new application, rewritten a feature at a time, a page at a time even, and Yeah, run it seamlessly for the client's users because it's integrated in the legacy application. We should note also that for this to work, we have to redirect all the calls that that application does to the server. We have to redirect it to the new app so the application can work. And on IIS, we do it like this, very simple. So yes, that was it for the demonstration. If you are interested in the edge and in working to the edge, we have many positions open. And if you don't find any position here, you can also send a spontaneous application to Salimata. And yeah, thank you. I don't know if you have any questions. So if there is no questions, I think maybe we can end here. Thank you very much to all for coming to this presentation.